Welcome everyone. Hopefully you're having a good week. I know I am. So I advertised what we were going to work on today, and that is, hang on a second, there we go. That is reverse Polish notation, and we're going to get there. So, but one of the things is, I went to the store here yesterday over my lunch hour, and I noticed that Polish sausages were on sale, so I picked one up, and that's what I had for dinner. So I am ready to go. So, hopefully you're all ready to go as well. Okay. Oh, I've got this paper up here for you. Let me get to that in a second. I'll come back to it. Can we just, is there a way to get the font bigger? Oh yeah, hey, look at that. Hey, I don't have to type, I can type now instead. Hey, look at that. If I would actually pay attention, I probably could have figured that out, I bet, huh? Arial black. That's not exactly good. Let's fix something that's a little easier to read. Arial? Yeah, that's not too bad. All right, let me make it plenty big here for those of you who have bad eyesight, or for those who don't and just want something big. All right, reverse Polish notation. Okay, so let me stop for a second and talk about something. Some of you already know how this works, although probably none of you have ever heard of this other than when I talked about it on Monday. Oh, let me stop. Still working on grading your exams. I've been kind of busy in my life, so it's taking a little longer than I had hoped. I'm trying to get through them as quickly as I can, and I'm hoping to be done tomorrow, although I'm not going to make any promises. But they will be done by the week, by probably early on the weekend. Okay. So, they recognized fairly early in computers that there's a problem with the way we write, formulas. Okay, right? So I could do, let's just do a simple formula, right? Like 2 plus 3 quantity times 4. Oops, geez. Yeah. Okay, equals. Right, and so we look at this and we say, okay, well, this is, you and I can figure this out, right? My guess is, right, this is pretty simple. 2 plus 3 is 5, and then we multiply it by 4, that's equal to 20. Right, we don't need to do a lot of work for that, right? We can just quickly do that in our heads, probably. All right, so the issue is the computer at the base level, remember, they can only read in one character at a time. They can't read in a whole series, they can't read this whole thing in, or they can't process the whole thing at the same time. They can only look at a single character. So when it sees this right here, what does that mean? Well, it means we're about to say some stuff that's going to have higher precedence than some of the things that are later. Right? Because we have to do it first. But how's the computer supposed to know when you're going to end? Well, it can know when it gets to this, right? But it has to remember that it's in a situation where it's having to do everything inside of those parentheses before it moves on. And the parentheses aren't necessarily the problem. Actually, the big problem is, because we read the 2 and we said, aha, a 2. And now I'm going to do something on it. And so I'm going to, when I see this plus, When I read the plus in, it says, do something with the 2. Add something to the 2. What should I add? In this case, we can look forward because we're humans. A computer can't do that. So it says it doesn't know that 3 is the thing it's going to add. Not yet. So this is the motivation for reverse Polish notation. Okay, I don't need to put this equals 20 here. If any of you have ever seen or used, I suppose you've probably seen it if you used it, although that's not required, an accounting calculator. People who are bookkeepers, or that's where I've generally seen it. They'll have a really big plus sign on them. And they don't have an equal sign, and that's actually important. Usually they don't. They might, but usually they don't. So those actually are reverse Polish is okay. Let me say it different. So this is called infix. This is infix. An infix notation means that the operator is between the 2 operands. Right? This is an operand. A and D. And that is an operator. Operate, or, not or. Sorry, operator. Come on. Okay. So the operator is, maybe it isn't O. I don't know. It doesn't matter. We're not in spelling class. I'm trying to see if it has the word in here. No. It probably does, but it's not bold, so it's not jumping out at me. So the operator's in the middle. But, so this one, I would say 2, 3, plus 4 times. This is what's called postscript, or postfix. Notation. What this means is, I'm going to give you the 2 operators first, and one of those could be the sum of the last thing we did. So it says, add these 2, it says these 2 things, I'm going to tell you what to do to them in a second, and then it says here's the plus sign. So you need to add those 2 things together. And we would have to make sure that there's a space between them, or that there's a, that doesn't look like the number 23. Now, we can also do prefix. So prefix is, I believe, goes like this. I'm not as familiar with prefix. Oh, well, you know what? Let's actually take a moment, a break here, and actually let me talk about how do I, let me bring this search on, but do that on the side here. How do I look things up? Like if I want some extra resources, above and beyond, I'm trying to get rid of that. There you go. Above and beyond what I've talked about in class, or maybe what's in the book, or any of the other resources. So where are the other resources? We are in an amazingly awesome discipline. And I'm going to tell you why. There's a couple reasons. One, it's filled with people who are good with computers. And there's this thing that they invented a few years ago called the internet. Hopefully everyone has heard about it because you're using it. So, in fact, you guys probably understand it better than I do, at least how to use it, because you've been doing it your whole life. Generally speaking, actually, this is a really neat thing. The earlier you learn something, the younger you are when you learn something, it becomes, it's like, it's just an innate, it's inherent. It just becomes part of you. It's just not even... So, like when it comes to, navigating around on the internet or on a computer, it comes second nature to you guys. Most of you. For me, it didn't come second nature, but I was in my late teens, early 20s when I was first exposed to some computers. Some Apple II... What did we use when I was in high school? Apple II GS. That was the model that we used. It was all in one. So the monitor and the keyboard was external. So that was the only thing that was different. And the mouse. But the computer was right in with the monitor. And we've gone back to that nowadays. To a certain extent. Okay, so... yeah. Anyways. Where did I trail off on this? I don't even know. Oh, man. Some days. Must have been my supper, I think. I don't know. Where is my... Did I... for some silly reason, I think I closed what I was actually... Yeah, I did. I closed the thing I had open just a second ago. So let me... Yeah, that's weird. Okay. All right. Okay, so I was talking about looking things up. That's right. Okay. So you guys, you're going to use the internet, right? Because that's what you use. Now, some of you are going to prefer the book, and some of you are going to like the book. And I think that it is a good book. I think it's one of the best books out there on this subject. It might be the best. But in our discipline, right, there's a lot of people who are good at computers, which means they know how to put stuff up on the internet, and they have for a very long time, which is really cool. Okay. The other thing is, generally speaking, I only say generally speaking, people's politics don't get involved in our discipline. This isn't true for all disciplines. All right? Philosophy, things like that. There's some political science, right? There are some things where, because computer science is still a science, it tends to not be political. And I'm going to explain why that's important, because that means you can usually trust things better online. Because there is no, it's not just politics, right? But it could be something else. Whatever, there's very little motivation for people to deviate from kind of the norm. And so in a lot of ways, we're united by that norm. Okay, so what do I do if I need to find out something more? What did I just do? I used Google or your favorite search engine, and I just typed it in. In fact, actually, it's not supposed to be 2 words. It's supposed to be there. There. Reverse Polish, or prefix. But this brought me straight to Polish notation. But wait a second. It's Wikipedia. Is that a good site? Can I use Wikipedia? Is that even legitimate? Some teachers will tell you, no, don't use Wikipedia because it's terrible. And I think you're right if you're going to write a research paper or something like that, because it can be edited. Here's the thing, though. There isn't a lot of motivation for people to put dishonest information in the math formulas that we're using in computer science, like Polish notation. So I can go to Polish notation and I can be pretty trustful that Wikipedia is correct. By the way, there are articles out there. They're kind of interesting to read about how Wikipedia is at least as accurate as any other encyclopedia ever has been. I tend to like it, although there are some examples of where it's horribly inaccurate. Okay. But I don't want Polish notation because Polish notation. Not reverse Polish notation, but Polish notation. Let's go to that. This tells us this fella's name. Jan even has a picture of him. He's the guy who developed it. So that's why we call it that. I can understand why they don't call this algorithm after his last name, because I'm not sure I could pronounce it. I'm not even going to try. It goes all the way back to 1924. And in fact, reverse Polish notation was first used in a computer with the Z4, I think. Reverse Polish, it's not here. But remember, the Z1, 2, and 3, they're all developed by that fellow in Germany, Zeus. Z-U-S-E. I think that's probably pronounced as Zeus. But, okay, so I can look here, and this will tell me. So now look, aha, this is actually nice. So this is in the exact same form that what I did. But it can be written in Polish notation as this. Assuming a given arity, blah, 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 blah. Okay, so did I get it right? Hey, it looks like I did, right? The plus goes, and then they just go, all the digits go in order. And we could learn some more about prefix. And so prefix would be is useful, potentially. Oh, but it's not, right? Because when we see the multiplication symbol, we don't know whether or not what we're supposed to multiply. So we can't multiply. Oh, that's a bummer. So somebody said, how about if we do... Oh, yeah, that's postfix. This is prefix. So he came up with this prefix idea, but somebody came along, right, and said, hey, how about if we do it backwards and do postfix? So postfix means we're going to give you the two numbers and then the operator. And you guys saw maybe a little earlier. This was just kind of, it came up when I was looking this up. This is the paper that actually introduces an algorithm on how to convert between infix to postfix. And this is developed by Dijkstra. And if you'll notice, there was a picture at the beginning of this video, and that is Dijkstra. That's a picture of Dijkstra as it appears on his Wikipedia page. So, and he developed this in 1961. And my guess, he was probably in his mid-20s at the time. By the way, ALGOL is a computer programming language. It's a programming language. So it would be similar to C, and C is a very early predecessor of Java, if you're curious. So the title here is written, I believe, in Dutch. Could be wrong. But it was translated. But notice here, see how it looks a little different? That's because this whole thing was published on a typewriter. And evidently, I think they made a mistake here and then they fixed it. That's why it's darker there. I want to come down here because there was a word that I was kind of going through this. By the way, look this up. It's pretty cool. There's a link to it on the Wikipedia page. It's pretty neat. Most of it is in a foreign language, not English. It's in mathematics, and that's kind of a foreign language. But I was going down through here, and I found one of my favorite words right. It's on page 10, I thought. Yeah, right here, right there. Lexicographically. So lexicographically, well, wait, we can look that up. Lexicographically. The editing or making of a dictionary. The principles and practice of dictionary making. Well, that's kind of cool. But lexicographic order, the lexicographic or lexicographic order is a generalization of alphabetical order. But it's more than that, because I'll talk about the dictionaries of sequences of order of symbols, or more generally of elements of a totally ordered set. So, alphabetically is great, as long as the only thing we have is letters. But which comes first, an A or a capital A? Well, alphabetically, there's the same. So we don't know. So we have to switch to something called lexicographical order. And then we get to decide that the capital letters are first. And all capital letters come before all small letters. And that's because that's the way they appear in ASCII. Fair enough. Okay. I've kind of jumped around a bit here, but let's come back to this now. How do I do the conversion? Okay. I'm going to give you a simpler version here, because what I'm going to do is I'm going to cut out the idea of a function. Because I could have sign functions or a maximum, like a maximum of a group of things or whatever, right? I could do some different things in there. Yeah. And that they take a different order of precedence, but they're kind of a special case, so we're not going to worry about those because we're just going to handle numbers here. So let's try this. Can I insert? No. Like this. Yeah. Let's go back. What were we at? 48 was a good one? And Arial. Okay. All right. So let's see here. Let me go ahead and make this into a numbered list. Okay. So read a character. Now notice I said character here because I don't know for sure what, and I'm going to call that character op1. I'm going to make this a little wide. I want to make this a lot wider because I'm going to use it up. Okay. The reason I did this is because now I can go inside of this. Oh no, I don't need to do that. I can keep it out here. Okay. If it is a number. Now I go in. Put OP1 into output Q. Let me stop for a second, because some of you won't know what that means. Okay. Let's take this and push it down a page or so I have some room here. Well, I can just insert, I suppose. Where is it? There it is. All right. I'll shrink it if I need to. Okay. So I'm going to introduce two ideas. One is a queue, and the other one is a stack. Hopefully you've already learned about them, but if you haven't, I'll give you a brief thing here. A queue is a word that we probably should use here in the United States way more often. It's a great word, and it is very descriptive, and we don't use it, and I don't know why, but we instead use the word line. So if you go to the new premiere of a popular movie at the movie theater, and there's a lot of people that have come there, you have to stand in line. You wait in line, and then you move up, and the first person there is the first person served. And we hope when we go to a restaurant that that's how we get served as well. It depends on, right? There's some variations on it, right? Like when they have two different order windows or order places and only one place where they serve it. So those two lines get merged, and that actually can introduce another word for us, but we're not going to worry about that today. So a queue is just an ordered list. But it's more than that. It's first in, first out. And we conceptualize that as so the first thing that goes into a queue is the first thing that's going to come out. So we can put things into an order in a queue, and then we can just output them all at the same time. Okay, the other thing, the next thing we're going to introduce here is a stack. There's a version of a queue called a priority queue, and a priority queue would be used at, say, an emergency room, right? Because if you go in there, right, because you smashed your hand in your car door or wherever, or your friend did, and you're in some pain and it needs to be taken care of, but if you have to wait a little longer, it's not a big deal, but if we've got a gunshot wound or somebody who was in a massively bad car accident, maybe those people should go first. And so then they move those people to kind of the front of the line. Or somebody who's had a heart attack or whatever. So, and we agree that this is, we generally agree. Although, if you're the one who's got the broken thumb, you probably don't agree. You think you probably are the one that needs to get in as soon as possible because, it really hurts. All right, so a stack is just that, right? In fact, I talked about it some last week, didn't I? Yeah, right? I just put the thing on there, and I just put another thing on top of it, and another thing on top of that, and another thing on top of that. And then when I go to look at them, I just take them off the top of the stack. Ordered. That's what I said. And so this is also an ordered list. But this one is called first in, last out. And we would definitely not want the movie theater to be there, because otherwise the person who comes the latest will get in first. And we don't like that. That's bad. Or you don't want the restaurant to be like that either, right? So if you show up at 5 o'clock, at 7 o'clock, because they've been busy and helping people out, you're still waiting for your food. Well, that would be a terrible thing, right? We won't want that. That's why they don't use it. Okay, but we're going to make use of it here. Okay, so, all right, those are the two ideas. Actually, it turned out that I didn't need that much stuff, Well, let's see, come back here. Yeah, I can bring this back up. There we go. All right. So now, let me back to home. Oops, wrong way. Okay, come back here. If op1 is an operator, all right, so now I'm going to define a couple terms, a couple things, and I'm just going to talk about them. Top refers to whatever's on the top of the stack. We can always just look at the top of the stack. We can't look at anything else in the stack. And in a queue, we can only look at the first thing in the queue. We can't look at anything else in the queue. And then when we put things into the queue, we always put them in the back. And we put things into the stack, we always put them on top of the stack. And then the other word, the final word I think that we're going to use is pop, and you can pop things out of a queue or off of a stack. Although in this case, our queue is always just going to go at the same time. We're going to do it at the end. It'll be for our output. So we're going to have a Q for output, so we're going to call that the output Q. Right, we've already used that word here. And so from now on, I'm just going to use the word Q. And then we're going to have a stack. And, yeah. So what we're going to do now is we're going to look at the top of the stack, and we're going to see if the top of the stack is a left-hand parenthesis. So, while top is not equal to a left parenthesis, and op2 oh wait, no, oh wait, we should say this differently. Well, op1 is not equal to a left parenthesis, and top, oh wait, has greater priority. Precedence. Than op1. Okay. If I could spell that, that'd be helpful, right? Be dangerous. Precedence. Okay. So let's give an example of what I mean here. What situation where we wouldn't do what's in the while loop here. Back to drawing. I've got this stack, and we're going to go through this in a second. We'll come back to it. Kind of work our way through it. Say I've got a plus here and a multiplication. Oh wait, no. Let me back that up. We've got. Oh yeah, okay. A plus here. And that's sitting on there. So if this is sitting on there, then what I'm going to do is op1, right, remember, is the thing I read in. So once I read in this parenthesis, the closing parenthesis, that means I'm about to start a new combination of things, right? So that means I'm going to skip over it. So in this case, right, if I read in a plus symbol, so let's say op1, or the thing I read in, is equal to this plus symbol. So another plus symbol just came in. So it's going to look down here and it's going to say, hey, wait a second. I'm going to skip this step because that's sitting there. Also, I'm going to change this out. If this is a multiplication, I'll show you. So 1 times 2 plus 3. What do I do first here? I'm going to do this part first. So this so if I wanted to do the reverse Polish on this, right, it's going to be 1, 2 times 3 plus. Because I'm going to do the 1 and the 2, then I'm going to do the multiplication. And then I have my 3, and then the 3 gets added to whatever the value that we got from this first part, which in this case is still 2. Okay. So the closed parenthesis just tells us we're going to have to, I'm sorry, the opening parenthesis, which is what this is, right? This is an opening parenthesis. That tells us that we're going to have to wait until we see the closed parenthesis, and then we're going to do everything inside those parentheses in order. In whatever precedent they're supposed to be in. Okay. So, but this says, right, if we get to, if we just read in another operator like this plus, and top has greater precedence than our op1 that we just read in, then we're going to do the while loop. Okay? Or same precedence and precedence and oh boy. Okay, hang on a second here. I think I'm just going to erase this. I don't think I need it. Be nice if it would push it down for me. Or same precedence, and OP1 is left associative. Oh boy, we need to figure out what that means, don't we? Huh, okay. So where do we go for that? Looks like this. We could go to order of operations. I could get a YouTube video. That'd be interesting. A YouTube video watching a YouTube video. Yeah, there we go. Precedence and associative. This is a pretty good site here. cs.ecu.edu. I don't know. I've seen lots and lots of stuff on their stuff. And I like it. It tends to be actually a little bit better. A lot of times on Wikipedia with these formulas, it gets they because people can go in there and try to add things that are very deep, even on some of the simple things. But I find a lot of times if you find an edu website, that those are really great to use because they're geared more towards actually learning the concept. Okay. Left associative. What does that mean? Similar, a production in the form N goes to NA is left associative. Left associative rule indicates that star is left associative. Done from the left to the right. Okay. That doesn't actually that helpful. Maybe Wikipedia will be more helpful. Left associative. Okay. The operators are grouped from the left. Okay, how about an example? Oh, yeah. This is right associative. Because you have to start here and work your way back. So 3 to the second, which is 9. And then 4 to the 9th, which is some big number. Right associative. In order to reflect normal use, they're usually left associative. Okay, this is good because the addition and subtraction, multiplication and division are all left associative. Okay, so we go back to our algorithm. If they're the same precedence and the new thing is left associative, that means it needs to get done before the other thing because they're the same precedence. Now realize that means that multiplication and division, right, have higher precedence than addition and subtraction. So you'll do them first. So that means what we're seeing is we're seeing a plus symbol or a minus symbol, and that's what we have on top. And since the new one we're looking at is left associative, we don't need to do anything. We're going to skip this part, and I'll explain that. You're going to understand it, I think, once we get through with the whole thing. Oh wait, what did I do? Here we go. Okay, I want this to be indented a level, and so this says pop the stack. Actually, yeah, the operator stack. Operator. Hey, it's going to figure out that we got it right now. Okay, so it says pop the operator stack into the output queue. Okay. So it says take whatever's on top of the output stack and push it on there. So that means we just read in, and if we read in an open parentheses, and top has greater precedence than what we're looking at. We'll see it. I think you'll see it in practice here. Hang on. So the next one is push op1 onto the stack. Oops. If op1 is a left parenthesis, push onto stack. If op1 is right parenthesis, while top is not equal to a left parenthesis and stack is not empty, pop stack into queue. So, and in some ways we need to kind of take a break here. When input is empty, right? Because we're going to, once we get done actually down to here, then we're going to just take a pot, we're just going to jump back up to the read again, okay? So I can maybe put that in here. Yeah, go to read, or number 1. So, and then we jump down here to when the input is empty, so there's nothing to read. While stack is not empty and not left, left parenthesis. Not stat, I should say, well, top. Pop stack into Q. Pop, not poo. Okay. Or pulp. Can I get this all? I can't. That's probably way more than I can get on one page, isn't it? That maybe is big, more than big enough. So let's make it just a hair smaller. About 28. That's still big enough to read? I think so. Okay. I want to hang on to this. I'd like to save that somehow. Yeah, I don't know how to put that all on the same screen. Okay. So we're gonna do an equation. Let's just do 1 minus 2 plus 3, parenthesis. This does not handle this. It doesn't handle multiplication like this, right? Because when we have a number next to a parenthesis like this in that place, that means multiplication. So let's go ahead and put the multiplication in there. Multiply by 4 plus 5 caret 6. Okay, that's raised to the power of, and that's actually higher precedent than multiplication and division. And then actually, let's go ahead and throw something in at the end here. Let's go divided by 7. Great. Okay. Let's put this, let's go ahead and go through this. All right, so we're going to have this Q over here. And I'm just going to right to left, I'm going to rewrite this as I go. But I'm going to keep track of my stack as I go. Okay, so read the character. I'm going to call that op1. Is it a number? Yep. Okay, just put it over here on the queue. Done. 1 space. Next thing, minus. Is it an operator? Yes. But because I just realized I did not finish this. Or I deleted it. Or same precedence and op1 is left associative. Yeah, somehow I deleted it. Oh, no, I've got it there. Okay. So, op1 is not equal to this, so that's good. Top doesn't have a value, so we can't have that problem. And we also can't have the same precedence. It's not possible, right? So, we're going to skip over this, and we're going to go down here, and we're just going to push it on stack. Okay, so we've got our stack over here. Here's our stack. And I'll erase things, or actually I'll just cross them out as I go. All right, so I'm going to put a negative sign there. All right, now I'm going to read the 2. That just goes straight on here. It's like all of the other numbers, just straight into the Q. Okay, space. Okay, so now we come to plus. So we read in the plus. Aha, that's an operator. The top does not have greater priority, right? They're the same priority. Oh, hey, that's the second part. Or same precedence, and op1 is left associative. Is negative left associative? Yes. That means that we pop the operator on the stack and put it into the queue. So we pop this off, erase it, and then we put whatever we just took out of there and put that here. Now we have space again. Now remember, we're still holding on to op1 is still that plus. Okay? So now the while loop is no longer true, right? Because it's empty. There's nothing in there to be the same on precedence or greater. So then we're going to push op1 onto the stack. Okay, so our plus sign just went onto the stack. Okay, now we're reading the 3. 3 just goes to the output because that's what we do with numbers. Now we read a multiplication sign. Top has greater precedence. Nope, op1 has greater precedence. And they're not the same precedence. So, there it goes, fired on top. All right, now left parenthesis. Op1 is a left parenthesis. Oh, that means that we don't go into this here. Okay, or op1 is is the same precedence. So if they're the same precedence, op and top, they're not. So we're going to, right, because a parenthesis doesn't have associative. It's not associative at all because it's just giving us a grouping. So we're going to push it right onto the stack. Is that right? Oh, no, it's not an operator. So we'll skip that part. So, but op1 is an open, it's a left parenthesis. So we're going to just push that onto the stack. Just push it right onto the stack. We don't even have to get to that while loop. All right, then we get the 4. That goes right there. Then we get a plus sign. All right, that's an operator. Op1 is not. Well, that can't even be. That's not even ever possible. Yeah, that's right. Okay. Something's wrong here. Because we shouldn't ever, when we get to this plus, we should never take this off of the stack. We never take that left stack, that left, and we should just throw it away. Great. Okay. So these two here, and then a minus, so that's good. Then we take that result and we don't subtract right away. That's why we have it, or add, I mean, because we have to do this multiplication first. So where it's going to be 4 space 5 plus. We're going to push this plus onto here. Yeah, something's wrong with that algorithm. And then when we get to this right here, now what we're going to do, not plus, I did the wrong thing here. Oh, no, that's right. That's going to get this plus here. So when we get to this right here, then we're going to go back and we're going to put the plus on there. And then until we get to so we're going to just put them all blah, blah, blah. Okay, so then we're going to get rid of that. And then we're going to get rid of the left parenthesis. Now we read here, this is still left, or left to right, but it has higher precedence. So because this has higher precedence, oh, right, but it doesn't have higher precedence, right? Top does not have higher precedence than up one. So we're just going to put the caret on top of the stack. And then we're going to put a 6. And then we come along with division. Now, division has lower precedence than what's sitting on top here. So that means this, that caret, needs to go on the stack. That goes on the stack. We erase. Then we put the division on top. Then we put our 7. And I'm going to need to grab all of this. Maybe move it a little bit over here so I have some more room. And then I'm going to put the division sign, multiplication sign, and the plus sign. All right. Didn't I see reverse Polish calculator? How to use? Nope. Oh, no. Infix to postfix converter. There we go. This actually is another good website, MathBlog. Okay, hey, let's put our formula in there. 1 minus 2 plus 3 times open parenthesis 4 plus 5 close parenthesis caret 6. And you'll notice here it supports slashes 7. Convert. 1, 2 minus. Oh, okay. So it saw this as, oh, that's right, because I did this wrong. I can't read instructions, can I? 1, 2 minus 3, 4, 5 plus 6. Oh. 6 caret 6 carats multiplication. So after we read the 6, or when we get to the 6, oh yes, okay. See, I messed up, didn't I? Because I didn't follow the rules. When I got to that division, right here, I should have noticed that these were the same precedents. Division, multiplication, same precedents. What do I do when they're the same precedents? I pop off the top thing, and then I reevaluate. Now I'm going to go ahead and push this on. And actually I did this wrong. Let's just get rid of them. Because I should do that before I still haven't read the 7 in. So then I read the 7 in. Then I put the division sign. And then the addition sign. And that's exactly what this actually comes out to be. Make some sense? Let's do another example. Let me turn here to our book and see if it has an example that we can use. Yeah. Yep. That's not gonna. Doesn't have anything on Polish notation. Yeah, not a single exercise. Well, that's gonna have to change. I'll have to make one up. Okay. Well. 5 times 4 plus 2 minus 1. Put this stuff in parentheses here. Caret 2 times 3 divided by 7. Doesn't really make a difference. Actually, I don't want this to be a 2. I want it to be a number that's a unique 8. Okay. So let's work through it. So here's our Q. I'm just going to put a single letter there, and here's our stack. A single letter. 5. So here's our Q, 5. I'm not going to put the space there because we're going to assume that that's correct. Okay, so then the X goes on top, or top of the stack. Boom. We see a left parenthesis. We put it on. See the 4? Good. See a plus? That's a that's on top. This oh, that's okay. We don't care about that. Then we put the 2. And then we see a minus sign. So the plus gets pushed onto here. And then we're going to, or popped off, sorry. And then we're going to push the negative sign on there. And then we're going to put the 1 on there. Then we see the closed parenthesis. Now, closed parenthesis says, basically, do that, and then pop that off, and pop that off. So now we'll go to put this caret on there. But the caret has higher precedence. Oh, but we don't care if it has higher precedence. That's okay. We can push it on there. It's if the top has higher precedence. So we push that on there. And then we see a left. Then we see an 8. And then we see a multiplication, which is still fine. It's all good. And then we see a 3. Now we see the right. So in the right, we're going to put that. We're going to plop off the top here. And then we're going to erase this and this. There we go. And then we see a division. Okay, but the caret has higher precedence in division. So now we do the caret. Division has higher precedence in multiplication? Nope. But it is left associative. So then we're going to do the X. And push that on there. And then we read the 7. And then division. All right, let's see if I did it right. 5 x 5 multiplication 4 plus 2 minus 1 caret open parenthesis 8 times 3 close parenthesis /7 Did I get that right? 8 times quantity 4 plus 2 minus 1, close quantity, caret, open parenthesis, 8 times 3 minus... Good. Convert. All right, let's look here. 5, 4, 2 plus 1 minus 8, 3 times caret times 7 divide. Postfix. Oh, to finish this off, I should probably have erased this. Right, because at the end I just need to put whatever's in that stack into the queue. All right, so how does a computer actually read this? It's going to input the 5, put that into the accumulator. It's then going to add the 5 plus the 4 and store it back into the accumulator. No, sorry. Let me back up. It reads it indifferently because it creates a stack to read it in. Reads the 5, reads the 4, reads the 2. So then when the plus comes along, it just takes the top two things on the stack, which is a 4 and a 2, and then it does the operator on them. So 4 plus 2, that's 6. Pushes the 6 back onto the stack. Okay? So now we're gonna decode this. So I'm gonna decode it. Or yeah, decode it. Decode's the wrong word. We're gonna work through it. Do the math, right? Do the math. Okay, so we have a stack and then an accumulator. Okay, so the 5 goes on the stack, 4 goes on the stack, 2 goes on the stack. We found an operator. So then we take the two things in the operator and then we do the stuff on it, right? So this would be op1 and this would be op2. So 4 plus 2 is 6. Put the 6 on the stack. Then we see a 1, push on the stack. We see a minus. So then we go 6 minus 1. So we pop those two things off, 6 minus 1, and that is 5. So we push 5 on the stack. Then we get an 8. Then we get a 3. And then we get a multiplication. So we're going to do that math. So 8 times 3 is 24. And then we have a caret. So now we have 5 to the 24th power. 5 to the 24th power. I'm not going to do the math on that. Times. Times 5. Oh. That is 5 to the 25th power. 5 to the 25th power. Divided by 7. Okay. 5 caret 25th power equals some really big number divided by 7 equals. There's our answer. Some really big number. All right, let's make it so it's not so obscene. Let's make this back to a 2. Actually, let's make that a yeah, that's fine too. And so then it'll actually be 5 to the 7th power. Right? Because 2 times 3 is 6. And then we're going to multiply it by that 5 out in front. So we're going to say 6. I made a mistake somewhere. didn't I? No. The 6th power. And then I push the 7 on there, and then I say 5 to the 6th divided by 7. All right, so let's do 5 to the 6th here. 5, no, clear. Completely clear. Clear everything. 5. I don't see it. Caret. Nope. That didn't work. Well, 5 times 5 times 5. 1, 2, 3, 4, 5, 6. Good. Divided by 7 equals 2232. Nope, 5. Oops. 4 plus 2 minus 1. Caret 2x3 slash 7. Did I write that correctly? It looks like I did. That gave me a different number. Something's got to be wrong with Google, right? Or did I make a mistake? No, I did this right. But when I was decoding it, what mistake did I make? Okay, well, let's just do the whole thing over again. Let's see. So 5, 4, 2. We see a plus, so we add those two together and we get a 6. 1. 6 minus 1 is 5. Oh, that's right. Okay. Where's my, there's my, so then 2 and 3, and then multiplication, so 2 times 3. Oh, that's why. 2 times 3 is 6. Then we see the caret here, so it's 5 to the 6th. That's probably where I made the mistake. I only took 5 to the 2nd, or 5 to the 5th. Very possible. And then multiplication. Oh, oops. So 5 to the 6th times 5 is 5 to the 7th. 5 to the 7th divided by 5. Same number. So that's my 11,000, whatever it is. It would have been nice if I would have come up with an answer that was nice and easy. But I didn't. Oh, it is what it is. All right. Yeah, I'll have to see if I can find a better algorithm, because something didn't quite sit right with me about the one that I gave you here, because this isn't quite right. It wasn't, or I wasn't using it quite right. It worked when I just kind of do it freehand, I guess, because I know how to do it. It's just a matter of not getting that algorithm quite straight. Okay, that's what I've got. And oh, that's why I couldn't find a proper problem, because I had flipped to the back of of chapter 6. Oh, well, jeez. Yeah. Yeah, there's some really good ones here, and we'll use some. So, oh, and it actually uses variables instead of numbers. But that's on page 346 of the book for those of you who have a book and are looking. Like I said, it's not required. You don't need it, so it's not a problem if you don't have it. Okay, I think that's everything I got for tonight. It looks like the oh, okay. Yeah. It looks like I've got a few of you have done that survey. So there's a survey on Blackboard. Is it am I talking the same thing? Is that what it's called? I get confused because actually I was talking to a friend of mine who uses a different system. Yeah, it's Blackboard. Okay, so anyways, no, D2L. It's not Blackboard. Blackboard is where they used at a different university I used to work at. Okay, so go out to the website for our class. There's a survey there. It's 2 questions. It's anonymous. I won't know who you are. Although, I mean, if you want to identify yourself, it doesn't matter. And so I think one of them has already been answered. I was asking if people actually still wanted these notes. Wanted me to actually put those out there. And it looks like there are enough people that want that. So I'm going to go ahead and keep doing that. I'll do that the rest of the semester then. And the other thing is I ask you to let me know if there's anything you think that I can do to help improve the course. So, and that is 100% confidential. So I won't even know who answers the survey and who doesn't. And it's not for points. It's just to be helpful and friendly and to try to improve my ability to help show you guys what to do. All right, that's everything I've got for tonight. Have a good 22 hours and 40 minutes for those of you who are watching live. For those of you who are not watching live, I'll see you in just a second for the next lecture if you're binge watching them. Okay, thank you very much, and we will talk to you guys soon.